On Software Engineering Daily, we often discuss big data in terms of data engineering and data science. Data engineering is the infrastructure and pipelines that handle massive amounts of data and puts that data into a data lake. With a data infrastructure in place, a data scientist can study the data and take action on it. A data scientist can also create visualizations, which is the subject of today's episode. Aurelia Moser has a specialty in mapping and data visualization. Today, we discuss how to create effective visualizations of our data and the tools that can be used to collect and present our data. Whether you work at the New York Times or a small tech company, whether you're a data scientist, a business analyst, or a marketer, data visualizations are important because data visualizations can be used to communicate important trends across an organization. After a quick break from a sponsor of Software Engineering Daily, we talk about data visualization and mapping with Aurelia Moser. As a software engineer, you have tremendous leverage in the employment market. Every company needs software engineers, and these companies are all competing for you, the engineer, a scarce resource. But as an individual engineer, you don't have much insight into this incredibly opaque market. That's where Hired.com comes in. Hired.com assigns you a talent advocate who works to understand your needs and works to find you the perfect job. Go to Hired.com/SEDaily to try out the platform today and get a $2,000 bonus if you find a job. The companies on Hired compete for you, the engineer, and they make bids to win your talent. These are companies like Facebook and Uber, companies that we know are on the cutting edge of engineering because they've come on Software Engineering Daily to talk about their tech stack. I've used Hired personally and I've experienced firsthand the ease of finding a well-paid, enjoyable job. This was way better than replying to LinkedIn messages from uninformed recruiters, and it was also certainly better than using a job search engine. To find a great job and support Software Engineering Daily, go to hired.com/SEDaily and get a $2,000 bonus upon finding a job. Check it out. It would support the show. Now let's get on with the show. Aurelia Moser is a community lead at the Mozilla Foundation. She has a specialty in mapping and data visualization, and she will be speaking at the upcoming Strata plus Hadoop conference in San Jose. Aurelia, welcome to Software Engineering Daily.
Thank you so much.
Before you worked as a software developer, you spent time working on data visualizations for the purpose of journalism, although I realized that there was software development in that role. But this is a great place to start our conversation because news is a prime example of how new visualization techniques and increased volumes of data, better software, all these things can lead to better products, in this case, news. So what is going on at the intersection of journalism and technology?
Oh, I think a lot of development work and a lot of, like you said, a lot of experimentation in the web development space, at least. A lot of libraries, too. People don't realize a lot of JavaScript libraries came out of newsrooms. So the New York Times, so like Backbone, Underscore, a few things that people outside of the journalism world use actually started in journalism. And I think journalism is doing a lot of things with data visualization, like the New York Times especially is putting out a lot of awesome data visualizations. There's groups like Vox and 538 that are basing almost all of their news output on data-driven journalism, which I think is great. But they're also journalism, I think, is a really good space to build skills as a developer. I think there's a lot of emphasis on being able to ascribe to really compressed timelines and being able to work on short sprints very agilely. So I really appreciated working in journalism. There were always new topics to explore. You get a new assignment every few weeks. You're jumping around all the time, and you feel very motivated to try new and experimental approaches to how to visualize the information and how to incorporate it into a larger narrative, because you get to work with material that's so interesting. So you get to work with things that are, fed to you through investigative reporters who are on the ground in other places. You get to work on stories that are maybe outside of your beat or your domain, but are really exciting, and it's fun to switch it up. So yeah, I'm not sure if that addressed everything of your question, but
no, it absolutely does. One thing I'm curious about is how do news organizations organize their data scientists and engineers? Because a lot of shows we've done, they're engineering organizations or engineers working with other engineers. How do journalists and data scientists and software engineers work together?
All right, that's a good question. I think it depends on the newsroom, actually. Some newsrooms don't have the budget to have a real compartmentalization of different tasks. So before I worked in news, I worked at a tech company, and we had a DevOps team that did all our deployment stuff, and I just did front-end things, and I worked with back-end engineers to do more of the back-end things. But there isn't so much of that breakdown in journalism. Sometimes you are the developer, and that means you do everything. And I think everyone's had experience with that, especially if you've worked in the stuff like the startup space. You're used to kind of wearing many hats, but I think it's especially true in journalism. A lot of journalists are learning to code. Those who haven't already, weren't software developers at some point or didn't have formal training in computer science. So there's a fair distribution of knowledge in web scripting languages and front-end programming. A lot of designers, too. I rarely worked with designers who didn't know how to mark up their own designs. So there's a lot of knowledge in front end, I think less so in back end, and often those people that are hired with that specialty are pretty strapped between projects. DevOps is a really underappreciated department. I think it's probably true in a lot of things, but especially in journalism, because people don't really understand the complexity of supporting projects that are going to be viewed by 1 million people maybe as soon as they launch, or election day projects where suddenly everybody's visiting the site and everything has to be perfect and up and has to be working, and the data pipeline has to be constantly streaming, and downtime is you experience those stresses outside of the news world, but your audience sometimes is a bit more empathetic, I think, when they know that it's a highly technical project. But I think people visit news sources online and they don't understand all of the technical muscle and capacity behind it. So they're less sympathetic to when the site goes down, or when it's not loading, or when there's incongruencies in how things are described in the text and the visualization that partners with it. So it's a lot of pressure.
Okay, that's fascinating. What did you learn about the DevOps of a journalism organization?
Oh, well, so when I worked in news, I worked with an organization that helps journalists. So I worked with Ushahidi and Internews Kenya. So Internews Kenya in East Africa did a lot of training materials that they would train journalists in how to use security software to protect their sources, and in how to do data visualization for their projects. But Ushahidi, in the same token, built a mapping software for journalists to use to collect on-the-ground stories to support their articles. So I didn't get to work in a newsroom like the New York Times or ProPublica or some of these other groups that a lot of the fellows who were affiliated with my same program at Mozilla did. So I only heard their stories, and then kind of the horror stories from my friends who are on DevOps teams about what it's like to work in the news world. It can be intense.
Okay, fascinating. So there are a number of news organizations that are trying to make a shift to having a greater focus on technology and data. Do you have any advice for how these types of organizations can make that shift?
Yeah, I guess. I think the groups that I mentioned before, Vox and 538, that are kind of pop-up shops doing great work in the data journalism area, are already kind of piloting this, but they're working in a more of a startup mentality, small shop of people all focused on data visualization and data analysis and data science in general. And it's harder for bigger orgs who are used to doing more traditional reporting to dedicate time and resources to data visualization projects or data analysis. But I think it usually works out pretty well when they partner with groups that make tools to help journalists or to just help the general public visualize or analyze their data. So I've seen partnerships in the past with IPython Notebooks, so journalists can publish their analysis along with some visualizations that are created so people can see the code, and then they can also see it paired with the resulting visualizations. I've seen a lot of, like at CartoDB when I worked there, we had a lot of partnerships with news orgs, and we would actually dedicate engineering resources to building projects that we thought were particularly promising and awesome because it's good publicity for our company, and then it's also great for the journalists because they have some more technical muscle behind their projects. So I think it usually works out well when they partner with third parties because most of the people who build tools would love to have a news story to showcase how their tool is useful. And most of the people working on the story, have a lot of great data, but they might not necessarily know what to do with it. So yeah.
That's okay. That sounds like a really synergistic relationship. So I want to talk about data visualization now that we've kind of glossed over maybe one mainstream use case for these improved data visualization techniques. In the past, data visualization was mostly about presenting simple graphs and spreadsheet data in Excel, but it's expanded into a much bigger world within software. One area within data visualization that you spend a lot of time on is mapping. So tell me about a recent example when mapping provided you with a useful visualization for your data.
Okay. So I worked on a project a little while ago with CartoDB where we did a partnership with this group at GDELT, which is the Global Database of Events, Languages, and Tones. It's a Google project that was funded to collect all of the news media published and then subcategorize it and tag it, and then build an API that would allow people to access those data and kind of understand, pockets of the world where people are talking about terrorism in the formal media, or pockets where they're talking about some other topic, and then compare that with social media discussions around those topics to see what are citizens talking about casually, and then what is the formal media reporting on. So they had this awesome API, but nobody was using it because it's a fair amount of documentation to figure out how to access and use all of the tags and data, and then how to parse through it, and also how to then visualize it into something that's meaningful and focus your analysis on something that's important to you. So we ended up working on a bunch of maps related to that API, and that project was awesome, but mostly because after we created these maps that would show people are talking about pollution, or there's a conference that's happening in this area, and we can kind of analyze the discussion based on formal media and also social media. And when we made this sort of accessible GUI where people could search for terms and then it would map the terms immediately, you really got a sense of the heat map of topics, and also gap areas where the most coverage about Ebola is happening outside of West Africa. So what does that say about our formal media? Or certain places where a topic or a civil war would not be covered at all in the local media, but would be overcovered by external media, and that leads to your suspicion that maybe some of their claims or facts are a bit specious because no one's actually on the ground investigating this. So it was a really interesting project, and then for us, and then afterwards we got some publicity from different media sources who wanted us to do particular analyses on what interests them and what topics they wanted to explore. So we started doing some more interesting machine learning on top of that to try to parse out, one journalist wanted to do an article on wildlife crime. So she said, okay, well, we want to do some research on poaching that's published in the formal media. But poaching, if you're looking through any article, published across all these different formal media outlets, could mean poaching for a hire. It could mean poached eggs. It could mean lots of different things that aren't related to killing animals. So it was an interesting challenge to try to write all the edge cases and figure out how we were going to, write something that had, or write sort of an extension to the API that would give some integrity to the map that was created at the end. So that was an awesome project. And I've also worked on a lot of different sensor data mapping projects, which are a bit more small scale because we were using like Arduinos and little hardware packages that we were building ourselves and sort of deploying them in small environments. For Ushahidi, we worked in Tanzania on this project to study agricultural sustainability and farming techniques in a particular region of Tanzania. And so we distributed all these sensors, and we also had people monitoring them. And then they had all this historical data from this group who had already been doing that. So we converted their data, we matched it with ours. We tried to create this timeline showing, or time series visualization of how, what the values of the data that had been collected. So they were putting these at different water gauging stations on rivers and trying to see what the water flow rate was and what the temperature was and how much access to that kind of irrigation different farms had in that area. And what we found in mapping it was that there were a lot of, there's always issues with data, especially data that's been collected since the 60s and 70s, because at some point someone had to transcribe that and everybody collects it differently. And so there were a lot of data mismatch issues, but we found huge pockets of the different regions that the data was just useless, or the values, had no units. And there were all these problems with the data. At the time that we were doing this project, the organization that we partnered with was looking for more funding from their funder, the Gates Foundation. And so building this map really showed, okay, well, we need to not talk about this region because we don't have any good data to support the claims that are being made about how effective this project is. We need to figure out what's going wrong in this region. And those discussions only happened as a result of visualizing the information.
That's fascinating. So, you mentioned this sensor stuff. And mapping the real world is heavily influenced by the capabilities that we have with sensors in the real world. What can you say about the state of IoT and how Internet of Things sensors, how that affects the data-driven mapping work that you do?
Oh, yeah, good question. So I work with a group that a few friends of mine started called NodeBOTS, and it's about developing scripting language libraries that allow you to access Arduinos. So I could write JavaScript to an Arduino using Johnny 5, which is one of the JavaScript libraries that lets you do that. And that's great because then web programmers have the ability to use hardware in their projects. So I've been working on that for a while, and I've done a few projects like the agricultural sustainability one, and then one that's a bit more close to my heart that is about mapping data about bee colonies in certain communities and trying to study the environmental factors that affect whether they grow or die off, because bees are dying globally, and it's kind of a big issue. But anyway, aside from that, I work on kind of small-scale hardware projects. So I'm not really into the indoor mapping space or not all of my little hardware devices connect and speak to each other. So it's not perhaps as sophisticated as some of my engineering friends who work in IoT. But I think the potential is exciting. I think there's some language around it that's a bit overambitious for what can be achieved, but it's kind of like the semantic web.
Ways?
I don't know. I feel like it's kind of like the semantic web. Like there's a lot of people who've been talking about it for a while, and some things are actually highly semantic on the web now. So I guess I can't really say that anymore, but I felt like that conversation just sort of stagnated for a bit. And I think there's a lot of discussion about the potential for Internet of Things to work like in connected fridges and having your whole, home office, all of your devices talk to each other and everything works together in this sort of harmonious tech setup.
Well, okay, so certainly that is more vaporware-ish than is the reality right now. But you mentioned this example of putting sensors in, I think you said different waterways in Africa and collecting sensor data based off of that. That sounds like a very like a actionable real world use case for what we would call IoT. Yeah,
totally.
So I guess that was what I was more curious about. Okay. I recognize that there is a vaporware-ish sort of conversation around IoT, certainly in America. And then there is some realistic stuff going on with IoT, whether it's in Africa or if it's in warehouses or something where they're loading lots of packages and stuff, and it's this highly controlled environment. I guess I was just wondering where you have seen this actually affect or drive real world use cases, or if there has been stuff you've seen. But
sorry, I misinterpreted you before.
Oh no, it's fine.
I think some of the most interesting stuff I've seen has actually been outside of the US. And maybe that's because I don't attend a lot of IoT events or conferences or things outside of the small group that meets up for NodeBOTS. But the sensor data project in Tanzania is really interesting. The bee analysis project that I started working on, actually, we started in Buenos Aires in Argentina and in Latin America and a few different locations where they had beehives. And some of the resourcefulness of the people who will set up your sensor kits if you send them to different parts of those countries is actually really remarkable. And people are really excited about collecting those data because perhaps they're not so saturated with all of the data.
What kinds of sensors can detect bee activity?
So beehives actually, all the environmental sensors, so temperature, the weight of the beehive will determine population too. The noise that they make can determine how happy or healthy they are. So you can also do audio sensors. There's a lot of things, a lot of different environmental factors. Humidity can also indicate how successful or long surviving the hive will be. There's a lot of stuff that I was just kind of ambient things that I was collecting just to see how it would affect our community, because there were some climate abnormalities in the area that I was in. So I thought, I wonder if that would kill them off or if they're very resilient in different locations too. When you compare data, those same environmental sensor setups, you can kind of see how certain environments really foster, bee growth and health, and how the weight of the hive goes down slowly. So you can tell that the bees are dying off and they're not surviving. And maybe, Norway is not the best place for a beehive. But so there's a lot you can tell from ambient sensors. And they're also cheap too, that you can make a really nice little starter kit for anyone and send it out to them for very low cost.
Engineers love automation, and Wealthfront automates your investing. As a software engineer, there are certain processes that you want to execute no matter what, like integration tests during a build. You wouldn't execute integration tests manually. You would use a continuous integration tool like CodeShip or Jenkins to automate your integration tests. Wealthfront is a tool to automate investing. Just like a continuous integration tool runs your tests automatically, Wealthfront can reinvest your dividends automatically and perform tax loss harvesting automatically. To get your first $15,000 managed by Wealthfront for free, go to wealthfront.com/sedaily and get started with Wealthfront's layer of automation on top of your portfolio. Wealthfront.com/sedaily. Check it out. It would support Software Engineering Daily, and you will get $15,000 managed for free if you sign up. Automate your investing. Get back to the things that you can't automate, like writing code. We're kind of talking about the data production side of things, and I'd like to kind of talk about the data ingestion and the data processing, data visualization side of things. We've done a lot of shows about these back-end architectures that grapple with giant influxes of data. So give me an idea of the interface between this giant volume of sensor data. For example, for a beehive, you could be taking readings, as often as you wanted to, and you could end up with basically as much data as you wanted to. So what is at the intersection of this data production, I guess, ingress point, and then the egress and the processing and the visualization of that data?
That's a good question. Because you're right, you could continuously take data readings. I think usually started with the sensor kit for the beehives, I kind of just monitored it for a few days, tried to put it in graphite and a few tools to visualize the preliminary readings and see what was interesting. And then ultimately I just kind of break it down into very human understandable chunks. So people understand, a reading every day or an average reading every week. But they might not understand, the utility of reading every second, or they might not even be interested enough to go to a little website that has a Cubism JS visualization of how it's changing over time. They might not be interested in that. They might just want to know, okay, this week out of the year, these were the average readings. The next week, they went down, or what went down and what was bad. So in translating it to visualizations, it usually involves mapping or changing the timestamps that you're dealing with to something that's human processable. And the same was true for the sensor data for analyzing water flow rates in Tanzania. The format that they gave me for some of the earlier data sets was text files that actually the naming conventions were all off for what particular station they referenced. It was kind of unclear at first when the data was collected. Like they would say every 2 weeks, go read the meter on this particular sensor set. And sometimes people would do it on time. Sometimes there was no entry. The data was pretty messy. And so just finding, okay, well, I've established now that I'm going to take a reading from this week, and then this week in the next month, and then this week in the following month, and just be consistent about what week I take. And regardless of how clear or consistent the data is, I'm just going to use that as my, starter set. And then from there, dive into maybe the more granular things if I decide that it's necessary to show ups and downs between those kind of milestones. So there's a lot of massaging. I did a lot of massaging of those data and translating them. There were a few scripts that sort of processed the text files that I was receiving and put them into a more machine readable format, and then and also cleaned out all of the empty null values. And sometimes too, people, when they're manually entering data, right, they sometimes enter in units, which makes it a string and not a numerical value. So trying to figure out how to go through and clean all of that in an automated way is probably the first step for me. And then after that, trying to figure out what the general trends show, what points can I pull out the most significant values that a reader would be able to process.
Do the front-end visualization tools have any problem keeping up with the volume of data?
Oh, that's a good question. No, I mean, not for... I used, for the visualization of the Tanzania data, there was a map that showed all the gauging stations, and you could select a particular station, and then it would pull up a few charts and graphs based on the readings from that station. And I used a more souped up version of HiCharts, which is a JavaScript library that lets you make a bunch of just charts and graphs, but it's called HiStock, and it's more for stock readings.
I've used that.
Yeah,
I love it.
Yeah, it's really cool. Fun. It's really nice, but it's a bit faster than HiCharts because it's made to read financial data, right? So It was a bit stronger. So I did do that. I've done things, like I said, with graphite and cubism for more granular time series, and I think those sometimes you have to search for a library that supports more intense amounts of data. However, in the newsroom and in journalism, you often work with CSVs. Your largest file will be maybe the largest amount of data you'll deal with is like election results. You don't really deal with huge Hadoop instances or lots and lots of data. So I deal with a lot of small scale things. Yeah.
So let's talk more about the development of data visualization tools. You've said that developing good visualization software is about developing something that is as reflexive as your eyes. What do you mean by that quote?
Oh, yeah, that's a good question. So actually what I'm speaking at Strata about is kind of related to using sensors as satellites, and satellite captures of the world can be stitched together into a really authentic view just because they're so detailed compared to some abstract data visualization of a map, for example. And I think when I think about building things for the web, I often try to make something that's that at least strives to be as complicated as your eyes. Mostly because your eyes have some of the most advanced compression algorithms known to man, right? And they're instantaneous. Like you look at, if you have good vision, at least, I mean, provided you don't have poor vision, you can look at something or a 3D environment and automatically prioritize and reprocess it and understand colors, understand depth, understand where you should be focusing your vision. All of those things happen so quickly. And with data visualizations, there's usually some kind of lag, right? There's a load time. You'll have like a scrolly wheel for waiting while something loads after you click a filter. Even when you're using a web map, right, you have tiles that are loading. So those need to be stitched together. And if you scroll too fast, you can see the tiles load. So you kind of see how it's not actually having the world in the palm of your hand. It's just a browser view of the world. And if you scroll too fast, you run off the page. So yeah, I think trying to make the user's experience as natural and as fast as possible makes them feel like they're really in the visualization and they really are immersed in it. And that's kind of like how we operate when we see things in the real world.
Okay, so you mentioned your Strata plus Hadoop talk, which is called Mapping the Matrix. Why is your talk called Mapping the Matrix?
Oh, that's a good question. I guess I love alliteration. And then also I feel like maps are something that have kind of myriad definitions in different disciplines, and matrices are the same. Like maps have different definitions in mathematics. They can mean like a smooth surface between manifolds. They're a data type in C++. They're a tag in some scripting languages. They're also like a geo-representation of our world. So we might be familiar with more cartographic maps, and that's often what I talk about. But people have also used maps to describe graph relations between entities, like in a character map in literature. So the definitions are pretty myriad, and matrices are the same, right? They can be as abstract as a situation or sort of substance within which something kind of builds or originates or develops or is contained. They can also be, I think I'll get a lot of attention just for the film reference. I'm sure people will attend just wondering what it's about. But also, I'm talking mostly about mapping scientific data and mapping satellite imagery. And I'm talking about mapping things at both the subatomic level, so doing like chemical mapping exercises, which people used our software when I worked at CartoDB to build models for subatomic interactions. They also used it for mapping with satellite imagery, mapping views of the world or our terrestrial world, and then also for mapping and geocoding things in space, so like things on Mars based on satellite imagery. So I'm working at all of the sort of scales from subatomic to cosmic, and I thought it was appropriate to have a kind of large scale talk title.
What are the commonalities from subatomic to satellite level of the types of work that you would do when building an effective visualization?
Wow, that's a good point. Well, I guess this is mostly talking about maps. So maps at their base are trying to relate two items to each other with some kind of reference or location, right? So you're geocoding your data on top of a base map. But I guess in any case, all of the maps you make, regardless of their scale, are kind of fictional representations of what you're trying to display, right? So we don't really know what things look like at the subatomic level. I mean, we can guess. We have some microscopic or even smaller imagery to suggest how things interact and how they work. But really, when you're mapping something at that level, you're building a model, like a best guess. And the same thing is true even when we map things that are larger scale, like mapping the world, right? Every projection is different. People are always arguing about the integrity of certain projections. You're really just looking at a 2D representation of what would otherwise be a 3D world, and that's always going to be a bit artificial. So I think the challenges in a lot of data visualizations are trying to make sure that that artistry and that artificialness does not get in the way of clarity and explaining an idea with some kind of concise visual language.
So as a mapper, I mean, are you trying to iron out the artifice, though? Like, it seems like as a mapper, you're trying to present a point. You're not necessarily trying to do it in the most realistic form of presentation.
Yeah, totally. Although I think some of the integrity of journalism, or at least the values of being a journalist with integrity, that you should try to maximally represent things with the most authenticity, is still true for data visualization. You're not trying to fool people into your agenda necessarily or your perspective. You're trying to honestly display the data and say, like, well, this is what I've observed about what is being displayed here, but you shouldn't notice anything that's particularly biased in the representation.
Right. Yeah, that makes sense. I mean, okay. So I was reading about the talk that you were going to give at Strata plus Hadoop, and there was this other quote from you that said, sometimes the tools to build maps can be as obscure as the data that we are trying to parse. What do you mean by that quote?
So I think a lot of people are very intimidated by data, and they kind of use visualization as a way to process it and make it a bit more manageable. So the data itself can be kind of obscure to you, especially if you have a lot of it. And then sometimes the tools that we make to process the data, the documentation is really bad. And there's still a barrier to entry. So journalists, at least, who are trying to figure out how to work on deadline, have to kind of parse their time between, okay, do I teach myself this tool that's supposed to help me process these data, or do I just go through it myself manually and don't use any kind of automation, because at least I'll understand what's there and I can dig into the data right away and not have this barrier to entry where I have to learn a new tool first. I think one thing that we really worked hard on and kind of still struggled with at the end when before I left CartoDB was making documentation that made it easy for people. And it's always really hard to do that when you're building tools. It's really hard to put yourself in the mind of your users and say, okay, well, not everyone is going to spend all day, every day with this with this library like I am. Not everyone's going to understand it. How do I make it accessible to the audience that I want to solicit? And so I think both are important considerations.
Interesting. Okay, so these days you are working at Mozilla. What kinds of tools are you helping to develop at Mozilla?
So I work on the Open Science team, which is an appendage of the Mozilla Foundation that does outreach not to journalists like I worked on before, but to scientists who are interested in open sourcing their research or learning about how to safely open source their data and all of the software that they write to process their data. So we develop a lot of tools that are for that purpose, for both like training scientists. So we have a lot of training materials on how to choose a particular license or what to do with certain data sets, how to clean them so that they're appropriate for release, what kind of platforms should you use for releasing both your papers and the data in tandem with that. Then we also do kind of smaller projects like Collaborate, which is an extension of GitHub that pulls scientific projects into this larger scientific community space where other scientists can join your initiative on a particular open source project, and then you can track and promote it in our community at Mozilla. So we work on that. We also work on study groups, which are kind of academic. It's a Git repo that lets people set up a quick, easy website for organizing a study group on their campus related to science and open science. And then we have all this curriculum that they can then fork and version and add back into our library and repository of different curriculum tools. And then we also have a fellows program where we fund postdoctoral candidates in the sciences or in the data sciences to work on a few projects for 10 months. And get funding from Mozilla to do that. So we have a few. We have one in Cambridge. We have one in Vancouver. We have one in the Midwest, and one closer to home here in New York. And they're all doing different scientific disciplines and different topics. But one of them right now is working on a tool called SlideWinder that allows scientists to fork each other's slide decks and kind of mix and match and remix different talk material, but while also citing the original like digital object that they created when they open sourced their slides. And then another one is working on this tool for creatives for science that brings a bunch of designers into the scientific community and allows them to easily kind of make comments on scientific papers or in visual representations that scientists create, because scientists are notorious for not being very good at data visualization, or at least creating kind of boring graphs or slide presentations that are, in Comic Sans and kind of unattractive. So this is a tool to kind of marry the designer community with the scientific community. And then we do a lot of fun random pop-up projects. Like we have a site, or I just bought the domain for openscience.lol because I found out you could buy .lol domains.
Oh, no way.
It sent me down a rabbit hole of buying all these .lol domains. But
how expensive are they?
They're like, I want to say it was like 35 or 39. It wasn't too bad. It's worth like buying your name or something. I don't know, whatever is an important topic for you. But we're going to make a little myth-busting site that showcases a bunch of scientific discoveries or things that have been subsequently debunked, or myths about if you open source your research, what will happen to it, or will someone scoop you? And we're going to try to debunk some of those myths so people are more enthusiastic about open sourcing their research.
Okay, that has piqued my interest. I've heard this paranoia about the academic community, the scooping thing. So is that a fallacy? Does scooping not actually occur?
No, it does. I think there's. I just read an article I didn't just read it. It was about a year ago. Someone wrote an article about the phenomenon of simultaneity in scientific discovery, and how often there are at least 3 people in the world thinking the exact same thing at the exact same time. And it's a strange, coincidence. It really has nothing to do with them, scooping each other, but ideas tend to emerge in clusters at the same time in history. So I'm not sure a lot of the competition could even be helped if scientists maintained, the closure on all of their projects. But I think it's starting to pick up in at least in our community and in scientific or academic institutions associated with the sciences now. I know like the university, I think Penn State, or maybe it's the University of Pennsylvania, just made it a rule that when they're hiring professors in the sciences, they have to come prepared with an open science approach or statement to what they would do about open source science research, because they're enthusiastic about soliciting faculty that are really pro open science. So I think it's building, people are a little less scared about it. But there are also tools like Mendeley and Figshare that allow you to share your scientific papers and submit them for peer review in a community. So it's opening up, but there's still a lot of stigma to, if I reveal that I'm working on this idea, someone's going to find better data and they're going to do more research and publish faster. So lots of egos.
I'm really glad I'm not in academia. As any frequent listeners already know, so zero sum. But that simultaneity thing that you mentioned, that's the most recent instance of that I heard about. I listened to this Planet Money episode about the origin of those hoverboards, the one-wheeled electronic gyroscopic balancing things. Apparently there's no single creator of that. It was like one of these. There is one guy who may have been the original inventor, but it seems like it was one of these simultaneous invention sort of things. Everybody saw all at once. Every factory in Shenzhen saw all at once that you could build these things, and then they started building them. So it's pretty interesting. So I'd like to begin drawing to a close. But I'd like to spend some time talking about the broader cultural interest issues that you're interested in. You're part of a program called Girl Develop It, which is a program I think it's based out of New York. And what are you doing as part of Girl Develop It?
So a few years ago, 2 friends of mine started it. One, Sarah Chips, who's a developer in the JavaScript community, and her friend Vanessa started. Vanessa also worked in finance and like programming for finance software. But Vanessa Hurst is still involved with the Girl Develop It project too. But when they both got CTO jobs at other companies, they asked if I wanted to move up from TAing classes to just helping out. So Girl Develop It, as a preface, we build curriculum, open source curriculum to teach women how to code, but also to teach anyone how to code. And we host classes, particularly for women after work and on the weekends, that introduce them to kind of the syntax of most of the web scripting languages, and also some backend languages and some iOS and Android for mobile developers. So we have a pretty nice curriculum library now, and several years after starting, we're at 10 years old now. It's a bit crazy.
Wow.
But so we just started doing small classes in New York to kind of build a nice, very strong female community in programming. And also scripting languages were an easy entry point because people, or at least most of my friends and myself included, I only took a few classes in college that would even be relevant to what I do now. And most of the things I learned on the internet, or I learned from other friends, or I learned on the job when I was expected to do something and just had to jump in and read some documentation and learn it. So it was an easy entry point because a lot of JavaScript and web programming is very visual. And people get the kind of satisfaction of refreshing the page after they wrote something and it changes, or even just going to a page and opening up, your console and editing the CSS and seeing how the page changes is really satisfying. So we got a lot of students in by showing them sort of that visual component, and then they stuck around to learn more. And then after that, some of them moved on to boot camps, or they became developers themselves. So now the project has 48 chapters in the US, and we're pretty big. We have 8,000.
Oh, wow, that is quite big.
Yeah, we have 8,000 members in New York, female developers and former students and teachers as well. So yeah, it's pretty awesome. So I do a lot of logistics now. I do a lot of curriculum review and curriculum development, and then I also plan classes. I teach some classes. I just wrapped up a class on Meteor.js. Or we also do introductions to frameworks and libraries too for our more advanced students. So yeah, that's kind of what that project's about.
Yeah, Meteors a great project. And I think it's I was talking about this with my brother earlier. It's kind of like the closest thing that JavaScript has to Rails, I think.
Yeah, I was going to say, I feel a little bit timid even teaching it sometimes because I'm always worried that if you teach too much magic, people don't learn the basics. They don't know why something is working. They just know that the documentation said it should work that way. And some things are so awesome, like the way it handles OAuth and how you have to do very little for some of that setup, which can be sometimes a nightmare to set up. But then sometimes I'm like, I shouldn't teach these new students a framework because what if they don't understand a lot of the basics? I don't know.
Well, I think this is one of these things. I think the more magic, the better. Like the more black box magic that does things for you, the better. Because the thing that you're just worried about is the drop off. And as long as they don't drop off, eventually they'll figure out that, this was black box magic and it's doing something under the hood more complicated, and I need to figure out how it does that. But whenever you're doing any type of teaching of programming, my opinion is that it's just you're constantly worried about, are they going to drop off? So, on Software Engineering Daily, we try to have an ongoing conversation about the issues around gender inequality in tech. And given that you're part of an organization called Girl Develop It that's 10 years old, I think you're someone that's worth asking about this. I saw a statistic recently that said 60% of women in tech reported being sexually harassed. And I'm assuming you're okay talking about this stuff, but from where you stand, is the gender inequality situation improving?
Yeah, that's a tough question. I think it's really hard to speak from any position that isn't your own. And I've had a lot of luck, I think, in the tech community. I always felt very challenged and interested and engaged and didn't really have a lot of problems personally, but I'm also very good at shutting people down verbally if they give me any trouble. So I'm sure the statistic is true, unfortunately. But I've always kind of seen it as, I worked in chemistry before I did web programming, so there also weren't a lot of ladies, and I'm kind of very used to it, so I'm not really upset or intimidated by it. I think one thing that is getting better is that I see a lot more women at things. So I guess that's a strange metric to judge something that's virtual, right? Or a community that's mostly virtual by saying, well, I see people in person at conferences, but there's a lot of androgyny on the web, and you don't really know where people are coming from. So it's really hard to assess that community and really understand what's going on until you go to a conference like OSCON or Strata or something. And then you see, okay, well, there are, 5 women speaking, or maybe, they take a picture with all of the women at OSCON and there's only 20, and you're like, wow, I never realized how few. But then you look at pictures from years ago and there were only 2, right? So now I think things are getting better, and I feel like a lot of my talks are well received. I never have a lot of problems with people being judgy or presumptuous about how I got a talk, or whether it was some kind of affirmative action on the part of filling a quota for women at a conference. I feel like the community appreciates a diversity of speakers and a diversity of contributors, and I've been fortunate enough to experience that side of it. So I think
do you feel strongly motivated to do something about the imbalance? I mean, I'm assuming I understand that you feel you've gotten lucky, but you also affirmed that you feel the statistic is realistic. The 60% of women reporting in tech being sexually harassed. Do you feel an obligation or a compulsion to try to reverse the course, or is this more of like do you see it more of as something you approach passively that will change over time? Or
well, I certainly haven't had any impulses to sexually harass men at conferences. Like, I've never had the reverse impulse exactly reverse, but I do think that's
not what I meant. In case the listeners are unclear, that is not what I meant.
But I think I do have it's sometimes stressful when you're at something where you realize that you're suddenly representing your gender, and you think, oh, if I can't ask a question, because if it turns out it's a dumb question, then everyone will say, oh, it's like that XKCD comic where, if a woman makes a mistake in math, then it's assumed that it's because she's a girl and she doesn't know how to do math. It's not because, oh, you're an idiot, you just don't know how to do math. So I think the same is true. Like, sometimes there's a lot of stress and intimidation about making sure that you're always on point, because you feel like you're going to be the representative for your audience of your gender, and that pressure is kind of stressful, and I do feel a lot of extra personal pressure to maintain our reputation as good contributors to the community and as intelligent human beings. And So I think I do feel that kind of pressure. And I also feel a lot I enjoy very much mentoring a lot of young women in programming, and I find that I notice patterns in their own insecurities, and I'm pretty receptive to it now. So I run a lot of like little volunteer mentorship programs and like code review sessions, and we have them at Girl Develop It too. We have code review and coffee sessions where people can come in and partner with a more experienced developer and learn about what's wrong with their code, or even fix their resume or prepare themselves for a technical interview. Like I really enjoy doing that, and the mentorship part I think is really important for minorities in tech.
So we've talked some about media in this conversation and how to present findings, how to present data. Software Engineering Daily is a media organization, and I'm always curious, how can we better approach this issue, the issue of women in tech? Is there a particular angle to take? Is there a particular underreported side of this, or what are some, what would you like to see light shined on in the area of women in tech?
That's a good question. I think I wish there was more public research about women-owned companies and women-run shops. Like at the science lab, we always get emails from male scientists who will say, "Oh, dear sir," and and we're 4 women who work. We're 2 software engineers and 2 women who are scientists. So it's very strange that we're always like, well, no, actually there are no sirs. But that's because we also don't publicize it too much. And I think there's a lot of lack of publication around women who, start companies and are actually the CEOs of tech companies or are working. And maybe there's a paucity of them, and there aren't a lot. But I would love to see more of that, because I think it's very motivating to hear from women who are really piloting a lot of things. Like I know Vanessa, for example, she started this group called Developers for Good, and then Code Montage, and got a bunch of funding from various like big tech funders in San Francisco to start a project that I don't think anyone even knows she leads, because she kind of downplays her own role in it. So yeah, I'd like to see more of that. I think a lot of attention is put on, oh, wow, people are abused really horribly at some conferences. And when young people get drunk, young men will say inappropriate things sometimes. And that happens. And it's really unfortunate. But I think a lot of media attention is put on unfortunate trolling, and not on, okay, well, where are the women? What are they doing? Are they contributing? And can we highlight what they're contributing?
Yeah, that's definitely the conclusion that I've come to so far, is try to highlight the tech aspects of it rather than the women aspect of it. And the women aspect of it is sort of obvious and springs out of the fact that you're interviewing somebody who is a woman in tech. Anyway, well, Aurelia, thanks for coming out to Software Engineering Daily. It's been super interesting talking to you. I look forward to seeing your talk at Strata, and keep up the awesome work.
Thanks so much, Jeff.